Nanoparticles are small, about 50,000 times finer than a single strand of hair, but they're revolutionizing every aspect of our lives. In medicine, researchers are developing customized nanoparticles the size of molecules that can deliver drugs directly to diseased cells in your body, greatly reducing the damage treatment such as chemotherapy does to a patient's healthy cells. Nanotechnology also holds some answers for how we might increase the capabilities of electronics devices, while we reduce their weight and power consumption. For example, nanotech solar cells can be manufactured at significantly lower cost than conventional solar cells. Sports fans will be happy to learn nanotechnology applications increase the strength of tennis rackets, reduce the rate at which air leaks from tennis balls, and fill any imperfections in golf club shaft materials. Is your activewear weighing you down? Making composite fabric with nano-sized particles or fibers allows improvement of fabric properties without a significant increase in weight, thickness or stiffness. Manufacturing and functionalizing materials at the nanoscale leads to a whole array of nanomaterials varying in size, morphology and surface characteristics. A full risk assessment of a chemical can be time-consuming and costly, especially if all data have to be obtained experimentally. For nanomaterials, the safety testing of every unique nanoform is virtually impossible due to financial, time and ethical constraints. But it is yet critical to obtain key information that ensure their safe use. Therefore, we need more efficient ways to obtain safety information. This is where Gracious comes in. Having received funding under the European Union's Horizon 2020 Research and Innovation Programme, Gracious stands to streamline the risk assessment process for nanomaterials. Gracious brings together first-class scientists from the private sector, academia and government to develop a novel, highly innovative science-based framework to enable practical application of grouping, leading to read across and classification of nanomaterials and nanoforms. Grouping has been suggested to provide an alternative intelligent method of streamlining the information gathering for risk assessment. Application of the Gracious framework will allow movements away from the case-by-case risk assessment paradigm, thereby improving the efficiency of risk analysis and decision-making for safer design of quality nano-enabled products. But how do we group? Step 1. The Gracious framework is used to identify a relevant group for a nanoform, or to assess whether several nanoforms could be grouped. Step 2. Identify the purpose of grouping based on basic physiochemical characteristics and exposure scenarios of the target substance. Step 3. Assess the applicability of a well-defined hypothesis for grouping, or develop a new one. Step 4. Use a combination of data, computer modeling and lab testing to assess whether the hypothesis is accepted or not. If it is, we can make a justified decision for grouping. If not, the hypothesis needs to be further refined, or more data for the individual nanoform needs to be generated. The Gracious framework will be delivered in the form of an e-tool and a guidance document. This will allow movements away from the laboursome and costly case-by-case risk assessments, improving the efficiency of analysing environmental and human health risks of nanomaterials. The resulting framework will also facilitate business decisions concerned with developing new nano-enabled products and inform safety by design practices. Gracious is enabling a future where the design of nano-enabled products is safer and more affordable. Interested in testing the framework? Find out more and register your interest today at H2020gracious.eu. This project has received funding from the European Union's Horizon 2020 Research and Innovation Programme under Grant Agreement number 760840.